Welcome back. This is lesson 3 of Machine Learning Zoomcamp session 9. In this lesson, we will talk about TensorFlow Lite. TensorFlow Lite is a lighter version of TensorFlow, and the big TensorFlow, the usual TensorFlow, is quite big. So if we take this package, the size of this package when unpacked is approximately 1.7 gigabytes, and this is too large. There are multiple reasons why we actually care about size. First of all, there is historical reasons. Previously in AWS Lambda, there were limits and it wasn't possible to have a package that is larger than 50 megabytes of size. I'm not sure if it's still a valid reason, because now with Docker, we actually have larger limit, like up to 10 gigabytes, I think the size of image. So maybe this one no longer applies, but there is another reason. We do not want to have a very large image. Large image is usually problematic because it means we have to pay more for storing the image, which is actually not that significant because when we keep it on S3, it's relatively cheap. But another reason is when we invoke the Lambda function for the first time, it takes some time to initialize the function. And with larger image, it takes more time. So first it needs to download the image, then run it. It's not only slower, but also we will have to pay for this time as well. And then actually when we do import TensorFlow, it's also not instant. It takes some time to even do import TensorFlow because it's such a large library. It needs to load many things. And then also the RAM footprint is larger. The solution for that is do not use TensorFlow, but use a lighter version of TensorFlow, which is TensorFlow Lite. And TensorFlow Lite only focuses on inference. So inference is when we do model.predict. This is what we call inference. And TensorFlow Lite focuses only on that. TensorFlow Lite is not used for training models. It's not used for anything else but inference. So with TensorFlow Lite, all we can do is do model.predict and nothing else. To be able to use TensorFlow Lite, we actually need to convert the model. So enough talking, let's actually see how to use it. So what we will do now is we will get a model we trained previously. So actually we will not use exactly the same model. We will use a similar model, the model I trained for the book. I have it here in releases. So this is slightly less accurate than the model we trained in the previous session, but it's a good model. I already have it available, and we can go to releases of the course repo and find it here. Let me just copy the link address, and now I can download it. So I'll save it as model, clothing model. Now I am downloading it. And now, so first of all, I want to show you Python I use is 3.8. Let's import TensorFlow. And let's import Keras. I use a relatively new version of TensorFlow. Yeah, it's a new one, 2.7, with the most recent one. I just installed it 5 minutes ago. What we want to do now is want to use this Keras models module, load model, for loading this model. So it's clothing model H5. And we'll just call it model. We can ignore these warnings. So it just tries to say that, okay, it cannot use CUDA and the binary is not optimized for this specific platform. For this particular case, it's okay. We can safely ignore these warnings. And now we want to classify an image using this model. So the image I have is a picture of pens that we used previously. This is the picture. So I'll download this picture as well. Pens, JPEG. And now to read the image, we use from TensorFlow Keras preprocessing image. We use the function load image, and then this is the image of pens that we have. And we actually want to load it. The size is 299 by 299. So this is the image we want to classify. And then the other thing we need to use is this preprocess function. So it's from TensorFlow Keras applications. We use our model as exception. We need to import this preprocessing. So we need two things here. So three, the model, then the load image function, and then preprocess input. So let me import NumPy as well. I forgot to do this. So first we convert our image into array. Then we turn this array into a batch of one image, and then we use the preprocess input function on that. So as the result, we have this array of shape one image in the batch, 299 by 299 by 3. And now we just use this predict function on X, and we get the predictions. So let me write this to an array. Now to make these predictions more meaningful, we need to have the labels. And for that, we can just use the code from the previous session. So go to deep learning, and we have notebook here. At the end of this notebook, we have these labels classes. I'll just copy them. And let me also copy the last thing. This is how we combine the labels and the actual predictions. So nothing new for us so far. And here we use plain TensorFlow. What we actually want to do is we want to use TensorFlow Lite instead of using TensorFlow and Keras. And the first step for doing this is we need to convert our TensorFlow model, our Keras model, to TensorFlow Lite format. For that, TensorFlow Lite already comes in usual TensorFlow. And remember, I said TensorFlow is big. It contains a lot of different things, including TensorFlow Lite as well. And in TensorFlow Lite, in this package, we have a thing for converting. It's called TensorFlow Lite converter. Actually, in this converter, there is a method from Keras model. This is exactly what we need. And we already have a model. It's here. And now we need to do the conversion. For that, we do converter.convert. As a result, we have TensorFlow Lite model. So now this model is converted, but we also need to save it. So what I'll do is I'll just go to TensorFlow Lite official documentation page. So we have a Python quick start guide. And in this quick start guide, all you need is a TensorFlow model converted to TensorFlow Lite format. So let's go there and copy the code. Then let's use this code. So I usually call this f out, not f. And so here, let's call it clothing. What did I call it before? So I call it clothing model. Before it was h5, and now it will be clothing model tf Lite. So let's execute that. I have a typo. It's doing the conversion right now. I'm not sure what this warning is. It shouldn't affect the result. Actually, what's happening under the hood is first from Keras model, we convert it to TensorFlow format called saved model. It's doing this right now. It saves the intermediate result of saved model to this location. And then from the saved model format, it saves to TensorFlow Lite. Now we should have it. So let's check. We have our original model from Keras, and then we have the model, this TensorFlow Lite model. And well, we can use this model now. It's a little bit more involved than just using Keras. So in Keras, we just use keras.models.load model. Here, it's a little bit more complex. We already have TensorFlow Lite. So let me do this. Import TensorFlow Lite as tf Lite. This is a bit simpler because later we will convert this code to just usual TensorFlow Lite. So we will not have TensorFlow with us, and it will be just easier to take this code that we're writing right now and convert it. So here we need this interpreter class, and interpreter class has a path to the model. So we have clothing model TensorFlow Lite, and we'll call it interpreter. And this is not enough. So we load the model. Now we also need to load the weights from the model to memory. In Keras, it happens automatically, but here in TensorFlow Lite, we need to write allocate tensors. I think what it's doing is it takes the model and puts the weights from this model to actually this interpreter. I can actually check what it's doing. Yeah, it's not very descriptive. Okay. But I know that if we don't do this, it will not work. So better do it. And then the next thing we need to do is we need to figure out what the input is. So remember, in case of Keras, we have this Keras model, and then we have inputs here and outputs. So Keras knew what the input to the model is, what the output is. So before Keras was doing all that, when we do predict, it knew what it should send to input and what it should get as the result. Here, we need to do this manually. So first, let's look at inputs. We have only one input. That's why here we have a list with one element. And here we have all the information about the input. So we know that the shape for this input is 299 by 299 by 3. -1 here means that it can be as many images as we want. And what we're interested here is this index thing. So let me write it, index. It says which part of the model is the input. This is where the input should go. Let me write input index. So we will actually have to use this 0. And then we also need to find out what is the index for the output. So in the interpreter, we have get output details. So these are the outputs. For the output, we see what is the dimensionality of the output, 10, because we have 10 classes, and we have index. Again, 0, because we have only one output. Sometimes in some models, there could be 2 outputs. In our case, we have just one, and we have index. This is our output. It means we have 230 things inside our model, and I think this is the last one there. So let me just write it to output index. So now we will actually need to use these indexes. There is this thing called set tensor. We have a neural network with many, many different elements. And now we can set one of these elements to something. So we can put some data there. Now we will use the input tensor, which is 0 in our case, and we will put our x there. X, if you remember, this is our already pre-processed input. This is our image of pants. We do this, and actually instead of using 0, I'll use input index. So now we initialize the input of the interpreter with this x. The input is initialized, and now we need to invoke all the computations in the neural network. By doing invoke, now what happened is we got the x, the input data, and we passed through all this, base model we have and all the layers of the neural network. And now we have the results sitting in the output index waiting for us. So now we actually need to fetch these results. For that, we use interpreter get tensor, and we do output index. And these are our predictions. These are the same predictions as we had previously. So I'll just call it preds. And I'll use the same code. Copy it. So this is the same code, and we see that this is still an image of pants. But now we used TensorFlow Lite for making this prediction instead of using Keras. So let me clean this code a little bit. So just group these things together. So here in this cell, we'll load the model and get the input index and output index. And here in this cell, we will have the actual inference. So we set the input, we invoke the model, and we collect the output. It's a bit more verbose. I don't know why there is no simpler way of doing this in TensorFlow Lite. Maybe there is, I just don't know about this, but this is how you do this. And then, we also do a bit of pre-processing at the end. So now instead of like here, we would just do Keras load model one line, and then another is model.predict. Now instead of 2 lines, we have 7 lines. Well, it's not as bad. It's still not too many lines. Actually, we have a few problems here. Here we use this X thing, which we already prepared when we were doing it here. Actually, to prepare the X, we needed to do this thing. Let me clean this code a little bit as well. So put imports at the top, loading the model here. Here we load the model, then we load the data, we preprocess the data, then we apply the predictions. So we have these 2 things, and both these functions live in TensorFlow. But as we mentioned earlier, we don't want to use TensorFlow. We only want to use TensorFlow Lite. And in TensorFlow Lite, we don't have this load image, and we don't have these preprocess input functions. So it means that we need to get them from somewhere. And let's see how we can do this. So I'll copy this code. Let's see. Removing TensorFlow dependency. So we have this code, and let's see how we can actually get rid of this code. First of all, this load image, we can take a look at the code. Load image Keras. What it's doing internally, it uses a library called pil, which is Python image library. So here this function is. Okay, so now we need to figure out what this image is. So this is from Keras preprocessing. Let's go there. And there is a project called Keras preprocessing. Then in Keras preprocessing, we have images. I think it's here in utils. Load image. So here it's doing a bunch of things, but the most important thing here is it just loads an image with pill. And this is what we can also do. So let's do here from pill import image. And now this is the syntax we use with image open. That's we do this for reading, and this is binary. This f in our image. Yeah, this is actually our image. And now what we want to do is we want to resize it. Size. I don't remember the exact syntax. I think the first parameter is a tuple, the size, and then we also specify how the algorithm for resizing. So there's a thing called interpolation. It figures out how exactly to resize. The default interpolation method is used nearest. So we just do that. I think I don't need to specify this here. And then I have a resized image. So let's see if that works. So I'll just copy this thing. So that works. So actually we did the same thing here. This is the size and this is the interpolation. And now we need to take care about this preprocess input. So for that, let's find out what kind of code is used there. So I'll go to Keras. So in Keras we have applications and we use exception, this one. And we have this prep input. And we see that here for this preprocess input, we use this ImageNet util. Then we have a function called preprocess input. Data format is none, and the mode is TensorFlow or TF. So let's see what we have there. Let's actually see what this ImageNet util is. So ImageNet util is a function here, is a module here, ImageNet utils, and we have preprocess input here as well. Here is this function. Remember the mode is TensorFlow. So NumPy input, let's see. So if the mode is TensorFlow, that's actually the code we need. It's just 4 lines of code. Let's copy it. And I call it process input. And we don't need that. I'll use lowercase x. And let's see. Yeah, I think we need also to specify that the type here. I think this preprocess input is doing some conversion, but we need to convert it to float 32. Yeah, so now it doesn't complain. This is, I think it's the same numbers. Let's check. So we still have the same predictions. But now we don't have dependency on TensorFlow. We found how Keras implements this, and we took this code, we extracted this code, and can use it here. Actually, there is a simpler way of doing this, so we don't even need to do all that. There is a library called Keras Image Helper. It's in my GitHub profile. Keras Image Helper, which is doing all that for us. And it doesn't do this only for exception. It can also do it for other models. And this is how it looks like. So we create a preprocessor. We say that we want to have a preprocessor for a model called exception. We want to specify the target size, and then it will handle this for us. Let me do that. So I'll have a separate import here just to make it look a bit cleaner. Yeah, of course, it complains it doesn't know what Keras Image Helper is. So we need to install it, Keras Image Helper, and just do pip install Keras Image Helper. Yeah, it installed it. Now we have it. And let me create a preprocessor. It has 2 arguments. The first argument is exception. This is the type of architecture we use, the type of model, and then the target size, to what size we want to resize our image. And then there are, in this preprocessor, there are multiple functions. So the first one is from URL, and the second one is from path. From path, it loads an image that is saved locally, like we did with Keras and with Peel. But there is also a method called from URL that just downloads an image. You don't even need to download it. And let's see. Now we have the same X as previously, and we can do the predictions, and we can take a look at the results. And the result is still the same. I can quickly tell you what is inside this Keras image helper. There is not so much code. Have the same preprocessing function as we just saw, just these 2 lines of code. But for other architectures, there is a different preprocessing function. Keras image helper knows for which architecture, which preprocessing function you need to use. So you don't need to go through the source code and figure out which one to use. For example, for ResNet, we need to use this Cafe preprocessing. And for exception, we need to use this TensorFlow preprocessing. And then there is a place where it keeps all this information. It's in helper, so it knows that for exception you need to use exception preprocessor and so on. For now, it knows only 4 models, but it's easily extendable. So using that is a lot simpler than going through the code and figuring out which part you actually need. But if you don't want to use this library for whatever reason, you can just do what we did here in this lesson. So maybe let me put everything together now in one place so we can see what we did here. First, we imported TensorFlow Lite, then we loaded the model, and then we already had the X. Here, we just invoked the model. So let me put this thing here. So as we see, we have 2 imports. We need TensorFlow Lite. We need this Keras image helper. Then after that, we load the model. Then we create the processor, and then we actually get the data. Then we do the prediction, and then we do some post-prediction processing. Let me restart it just to make sure that if we start from scratch, that I didn't forget to import anything. So we'll load that first, then we load the model, then we create the preprocessor, we load the data, we invoke the model, and we do the post-processing. It seems I haven't forgotten anything. Last thing we need to talk about is this line here. Here we still use TensorFlow Lite that comes from TensorFlow. So we don't use a separate package. And I told you that there is a way to use a separate package. So there's a way of not depending on TensorFlow. Now let's talk about that. For that, let's go to TensorFlow Lite's website. So we have TensorFlow Lite website, and then we go to Getting Started Guide. And in the Getting Started Guide, I think we need to have Python Quick Start. And here, what we're interested in is this line. This is how we can install TensorFlow Lite runtime without TensorFlow. So this is only the TensorFlow Lite part that contains the inference. Let me execute this thing here. There is a bunch of extra parameters that say where it should go to get the libraries. Now it got the libraries, and we need to replace this import. Now, instead of from TensorFlow.Lite as TensorFlow Lite, we need to import TensorFlow Lite runtime as TensorFlow Lite. Runtime is the thing that lives in this package. Let me restart the kernel just in case. So that. And now we think it's from TensorFlow Lite interpreter as TensorFlow Lite. Yeah, so now it should work. And the rest is the same. And this is what we actually want to deploy on AWS Lambda. So we don't want to carry TensorFlow just because there is a module there Lite with it. So we want to use only runtime, only the smaller part of that. And that's all for now about TensorFlow Lite. And what we will do in the next lesson is we will take this code that we have here and we'll extract it from the notebook, and we will put it inside a Python script that we'll later put to Lambda. See you soon.